Today we're going to be talking about measures of center. And you've heard of all these before. The first one we're going to talk about is the mean. The mean of a data set is the measure of center. If we imagine that the data is weights, then the mean would be the point at which the data set balances. It's right in the middle. And we need to know some notation. Now, it depends on whether we have the population or sample data. If we have the entire population data, we use the Greek letter mu, and it looks kind of like this. It's a little like a fancy U or a fancy M. Now, if it comes from a sample, we put an X with a line over it. It's called X bar. Now, computing the mean is the same as you've always done it. You're going to add up or find the sum, and this notation means sum of all your X's and divide by your sample size. And if you were doing the whole population, you would add them all up and divide by your population size. Now, first example, we have only 5 pieces of data, so we would add them up. 78 plus 83 plus 92 plus 68 plus 85, and then divide by 5, because that's how many pieces of data we have. I believe I got 81.2. And since this is a student took 5 exams, this is the population, this would be mu. Now, another type of center that we could use is called the median. And it's just another way to measure the center of the data. Now, the median is a number that literally splits the data set in half. Half the data values are less and half are greater. The procedure for computing the median differs depending on whether the number of observations in the data set is even or odd. So let's do a couple of examples. Let's use that beginning example of those grades. And the first thing we do when we're trying to find a median is to write them in order. So the smallest one would be 68. Then we have 78, 83, 85, and 92. Now, since we have 5 pieces of data, we're going to go in an equal number on each side, and that would leave our median as 83. Now, what if we have an even number of values? So on this one, let's see, I have a 12, I have a 13, I have another 13, so 12, 13, 13. I have a 15. I have a 19, 20, 21, and 27. So this time I have 8 pieces of data. If I go in an equal number each way, I'm actually between 15 and 19. So we literally go between 15 and 19 and find the average of those, which would be 17. We're finding the number in between those. Now, you can find all these things on the statistics app on NumWorks. So let me change over to my NumWorks app, if I have it on here. There it is. So if you go to the statistics app and you type in your values, so let's see, what were those values we had? $78, $83, $92, $68, and $85. Okay, if you go up to where it says stats, it gives you the number of data points, the minimum, the median, it also gives you some other stuff we'll learn about. It gives you, and note that this first one is the mu symbol. That's the population mean. And if we go down, we see sample mean, and it has an X bar. We'll learn about some of these other pieces soon. But that's all you have to do to actually find it in the calculator. Now, we consider a statistic resistant if its value is not affected much by extreme values, large or small in the data set. The median is resistant, but the mean is not. And let's look at how that works. So 5 families have annual incomes of $25,000, $31,000, $34,000, $44,000, and $56,000. Let's see what happens. One of these families is winning the lottery. Let's calculate the mean and the median for each of those sets before that person won the lottery. So just using these pieces of data. I'll give you a moment to calculate those up. I got a mean of 38,000 and the median was 34,000. Now, what if that 25,000 changed to 1,025,000? So 1,025,000 plus 31,000 plus 34,000 plus 44,000 plus 56,000 divided by 5. Now the mean is $238,000. The median is still, well, actually median would move up because 25,000 is now the high one. The median will be 44,000. But notice there's not that much of a change in the median, but the mean changes a lot. That also affects the shape of the data. If the mean and the median are basically the same, that happens when we're symmetrical. The mean and the median will be the same because everything's nice and even. When we're skewed right, that usually means I have large values out on this side. What that's going to do is that's going to pull the mean toward those large values. It's going to make the mean get bigger. So the mean would be greater than the median if we're skewed right. If you're skewed left, that means I have a really, really, really small value, an extra small value. That's going to pull the mean to the left. So the mean is less than the median if we've got a left skew. Another value that you learned for center is the mode. The mode of the data set is the value that occurs most. Now, if 2 or more values are tied for the most frequent, they are both modes. And so we are considered bimodal. And if the values all have the same frequency, we say the data set is uniform. Nothing appears the most. So we have 10 students. They were asked how many siblings they had. The results arranged in order is thus. Find the mode. Well, the one that appears the most is 1. Now, the mode is sometimes classified as a measure of center. It's not really accurate. Mode is a lot better for qualitative data. For example, What if we had a list of all of the makes of cars rented by an automobile rental company on a particular day? What make of car is the mode? Wouldn't they want to know that? So they have that make of car handy if that's the one that's the most rented. So they would go through and we would count. Hondas, I have 1, 2. Three, Ford, 1, 2, 3, 4. It looks like it's Toyota. Now, sometimes we don't have access to the raw data, and we're given a frequency distribution. We kind of talked about this when we were building our histograms, that we can't use we can't put in the full split like the 0 to 49 in our calculator or in our calculations. So what we're going to find is the class midpoint. Oops. Whoa, I can't write. Class midpoint. The class midpoint is actually from here to here. So 0 to 50, the midpoint would be a 25. That's the midpoint of that class. The next one would be halfway between 50 and 100. Between 100 and 150. Between 150 and 200. And then we'd have 275. Now, if you were doing this by hand, you would say, I have an average of 25 10 times. So you would do 25 times 10 plus 75 times 5 plus 125 times 13 plus 175 times 11 plus 225 times 7 plus 275 times 4. And you could do it by hand that way. Or, if you're in the NumWorks app, when you go to your data set, you could type in your midpoints. And then in the frequency column, put the frequency for each of those classes. Then, when you go to the stats, you can find your mean. Now, notice the mean and the sample mean are actually the same value because it doesn't know if we were given the population or a sample. We need to know whether we were given a sample or a population. So that just changes not how we calculate it, but how we write our notation. And it did say this was from a sample, so this is an X bar of 137. Now the next thing we're going to look at, and it's actually the last thing for today, is when we have what is called a weighted mean. And a lot of times this happens when you have grades. Now, at Lindale, we have 50-50 grades. But at a lot of schools, certain values are weighted differently. Certain classes are weighted differently. In college, you have classes that are 3-hour credit, 4-hour credit, 5-hour credits. And your grade is weighted based on the number of credits. So let's look at, and I know I'm kind of skipping the formula, but I think it works better to just look at an example. Okay, so we're going to look at the class, the number of credits, and the points for the grade. Okay, so in stats, he got an A. Now, the stats class is a 5 credit hour class. That means they meet 5 hours a week. And if he got an A in the class, an A is worth 4 points on his GPA. The next one is psych. And in psychology, he got a B. Psychology is a 4 credit hour class. And a B is worth 3 points. Then we have English, which is he got a C, 3 credit hours, and a C is worth 2 points. And then we have music, and he got an A in music. Music is a 2-hour credit class, and an A is worth 4 points. So what we're going to do is we're going to multiply these together. So we've got a 20, 12, 6, and 8. Multiplied 5 times 4 and so forth. So this is his total points, 32, 46, divided by his credit hours. So the credit hours, he's got 14 credit hours that semester. So 46 divided by 14. Gives him 3.29 GPA. So even though he made an A in 2 of the classes, this A didn't count as much as this C or even this B that brought his grade a little down. So that's how a GPA is calculated in college.